Good day and welcome to today's webinar. My name is Isak van Niekerk and I'm based in the RIB Canny offices in Cape Town. I am involved in the testing, training and user support for Canny software. Today our focus is on the innovative feature in Canny's project control software that assists in the calculation of the carbon factor for projects. As sustainability becomes more important in how we plan and manage projects, tools like this can really help align your goals with being eco-friendly. The agenda for today is as follows. First, the introduction, explanation of what CO2 emissions is and how it's calculated. Then we look at the basics of the carbon factor. We will look at project lifecycle stages and modules in calculation of carbon emissions and where does Canny fit into this lifecycle. Thirdly, we'll look at the carbon factor input into Canny. That will be both resource input, bill input, and mention will also be made where some of these factors will be sourced from. Then we'll look at the carbon factor analysis, on-screen documents and graphs, reports available for printing. We'll also look at carbon forecasting, using Candy's unique capability of establishing a dynamic link between the bill items and activities in the schedule. Then we'll look and explore what-if scenarios, like leveraging the global variables and alternative tenders, functionality in Candy to analyze and identify strategies for minimizing the carbon impact of a project. Note, today's presentation is recorded and you will receive a link to download it. There are regular webinars on various Candy topics, and should you not be able to attend a webinar at a given time frame, then please still register for the webinar, as this will entitle you to receive a link to a recorded copy of the webinar. As this webinar is pre-recorded, we will not be able to answer any questions during the webinar. Please email any questions that you might have to your local RIB Canny offices. We will then collate these questions and send the answers to everybody that registered for this webinar via email. The topic of carbon factors is as fascinating as it is complex. It's a dynamic and evolving subject shaped by ever-changing policies, practices, perspectives, and different opinions. Acknowledging this, we have enlisted the support of artificial intelligence, mainly Microsoft Copilot, to assist with the research and explanation of these intricate topics. This ensures that insights shared today are as current, comprehensive, and accessible as possible. To make the webinar experience more interactive, QR codes will be featured on the presentation slides, and if you are watching the video playback, you can pause and scan these codes to access the primary resources that support the key statements shared. This gives you the chance to explore the material in greater depth whenever it suits you. So let's discover how this tool can drive meaningful changes, not just for your projects, but for the planet. As Elon Musk fittingly said,
We're running the most dangerous experiment in history right now, which is to see how much carbon dioxide the atmosphere can handle before there is an environmental catastrophe.
Let's look at the basics regarding the carbon factor. And for this, as mentioned, we will enlist the support of artificial intelligence. We'll ask Microsoft Copilot to assist with the explanation of these topics. Kindly explain what is meant with carbon emissions.
Greenhouse gases are substances in the atmosphere, such as carbon dioxide, methane, and nitrous oxide that contribute to global warming. Carbon dioxide, CO2, makes up roughly 76% of global emissions. For this reason, carbon is often used as shorthand for greenhouse gases. Broadly speaking, there are two ways of categorizing the greenhouse gas emissions associated with buildings. 1. Operational carbon, the emissions associated with energy used to operate a building, and 2. Embodied carbon, the emissions associated with materials and construction processes over the whole life cycle of a building.
What is upfront embodied carbon?
Embodied carbon emissions are generated by the manufacturing, transportation, installation, maintenance, and disposal of construction materials used in buildings, roads, and other infrastructure. Upfront embodied carbon, also known as upfront carbon, refers to the greenhouse gas emissions released before a building or infrastructure starts being used, which are largely from manufacturing impacts. This is particularly important for reaching 2030 climate targets because these emissions will be front-loaded in the next 10 years, unlike annual operating emissions or end-of-life emissions, which will occur later and/or gradually over time. According to the World Green Building Council, upfront carbon will be responsible for half of the entire carbon footprint of new construction between now and 2050, threatening to consume a large part of our remaining carbon budget.
What is operational carbon emissions?
Operational carbon emissions are generated by fuel consumption for heating, cooling, supplying fresh water, ventilation, and power over the course of a building's lifetime. The total carbon or whole life carbon of a building is the sum of both embodied and operational carbon. To reach net zero total carbon, a building must minimize both the operational and embodied carbon over the building's life cycle and offset any remaining carbon with carbon offsets.
So then what is the impact of the built environment?
The impact of the built environment. When considered over the full life cycle, including embodied carbon, the impacts of the built environment are spread across nearly every sector of the economy. Many of the materials we use in construction, such as concrete and steel, make up large proportions of industrial emissions. When building materials are shipped to processing facilities, construction sites, or landfills, those emissions are tracked as transportation emissions. The production of building materials contributes to agriculture and land use change due to the growth and harvest of wood and other bio-based building products. Finally, when buildings are demolished, much of the building ends up in landfills or incinerators, where their decomposition or combustion is tracked as waste emissions. For this reason, it can be hard to untangle and estimate the true global impact of embodied carbon in buildings as a whole. The largest contributor to global emissions by end use is the industrial sector, contributing 30% of global emissions. Building materials are one of the largest sources of industrial emissions, which means that they are potential drivers to reducing emissions from this sector. The top two industrial sectors alone, steel and cement, are each individually responsible for more emissions than all of commercial building energy use each year. A significant portion of these materials are used in buildings and other infrastructure. In addition to being the largest sector, industry is also frequently cited as the sector with the hardest to abate emissions for two key reasons. 1. Many key industrial processes require high-temperature heat that cannot reliably be replaced by clean energy yet. 2. Process emissions from industrial and fuel transformation processes release CO2 and some other pollutants directly into the air. For example, approximately 60% of emissions from the production of cement are process emissions that cannot be reduced through fuel switching. For these reasons, industrial emissions cannot be reduced only through a transition to clean power and electrification. Architects, in collaboration with other designers, builders, and clients, are perfectly placed to help push for solutions to global emissions from manufacturing and other sectors by doing the following: minimizing the need for high-carbon materials and processes through building design and the system selection, and creating demand for clean manufacturing practices by selecting and specifying products from suppliers that have improved their operations and supply chains.
How do we calculate embodied carbon in buildings?
Calculating the embodied carbon in buildings involves assessing the carbon emissions associated with the production, transportation, and construction of building materials. To calculate the emissions, multiply the quantity of each material used in the construction project by its carbon emission factor to calculate the total embodied carbon for each material. The carbon emissions factor information associated with each material is often available in environmental product declarations, EPD for short, which provide detailed information on the environmental impact of products. Add up the embodied carbon of all materials to get the total embodied carbon for the building project.
What is the carbon factor?
The carbon factor or emission factor is a coefficient that quantifies the emissions produced per unit of activity. For example, it can represent the amount of CO2 emitted per kilowatt-hour of electricity consumed or per liter of fuel burned. These factors are crucial for calculating the carbon footprint of various activities and are often expressed in units like kilogram CO2e per unit of activity.
What is CO2e?
CO2e stands for carbon dioxide equivalent. It is a standard unit for measuring carbon footprints. CO2e expresses the impact of different greenhouse gases in terms of the amount of CO2 that would have the same global warming effect. CO2e translates the potency, how much infrared radiation a ton of each gas absorbs, and longevity, how long a ton of each gas radiates the heat back to the atmosphere, in relation to the emissions of a ton of carbon dioxide. This is done using a metric called the global warming potential, which compares the warming impact of 1 unit of a given greenhouse gas to 1 unit of CO2 over a specific time period, usually 100 years. For example, methane has a global warming potential of 25, meaning 1 ton of methane has the same warming effect as 25 tons of CO2 over 100 years. Therefore, 1 ton of methane would be expressed as 25 ton CO2e.
So how is CO2e measured in construction?
When we talk about kilogram CO2e or carbon factor, in construction, we're referring to the amount of carbon dioxide equivalent emissions associated with building something. This is a way to measure the environmental impact of a construction project, considering not just carbon dioxide but other greenhouse gases as well. The E in CO2e stands for equivalent, meaning it's a combined measure. Carbon emissions in construction are a significant concern because the process of building and maintaining structures contributes to the overall greenhouse gases released into the atmosphere. These emissions come from various sources, including the production of construction materials like concrete and steel, and the energy used during the construction process and the building's lifetime. For instance, the energy needed for heating, cooling, lighting, and operating equipment in buildings can lead to high levels of carbon emissions. According to the United Nations Environment Program, the building and construction sector accounted for over 34% of energy demand and around 37% of energy and process-related CO2 emissions in 2021.
What is lifecycle assessment, or LCA for short?
A life cycle assessment, or LCA for short, is a systematic method used to evaluate the environmental impacts of a product, process, or service throughout its entire life cycle. This includes every stage from raw material extraction, production, and use, to disposal or recycling. Life cycle assessment is crucial for understanding and managing the carbon footprint of products and services. It helps identify the most carbon-intensive stages and provides insights into where reductions can be made, supporting efforts in decarbonization and sustainability. In construction, these emissions are divided into 4 different life cycle stages of a construction project. First, there's the product stage, which includes the extraction and manufacturing of materials. Secondly, the construction stage accounts for the actual building process. After that, the use stage covers the building's operation. And finally, the end-of-life stage includes demolition and disposal. Each stage has its own unique impact on the total emissions, and understanding this helps to find ways to reduce the carbon footprint of buildings.
Explain the life cycle modules per stage.
Product stage, also known as cradle to gate, include modules A1 to 3, kilogram CO2e released during extraction, processing, manufacture, including prefabrication of components or elements, and transportation of materials between these processes, until the product leaves the factory gates to be taken to site. Note that whether a product is recycled after its end of life or not, the A1 to 3 impact of the project being considered is not affected. This is taken into account in Module D. Construction process stage include modules A4 and A5 kilogram CO2e released during transport of materials and products to site, the energy usage due to activities on site, like site huts, machinery use, etc., and the kilogram CO2e associated with the production, transportation, and end-of-life processing of materials wasted on site. Use stage includes modules B1 to B7 kilogram CO2e released due to use, maintenance, repair, replacement, refurbishment, and operational energy and water while the building is in use. End-of-life stage includes modules C1 to C4, kilogram CO2e released during decommissioning, stripping out, demolition, deconstruction, transportation of materials away from the site, waste processing, and disposal of materials. There is one additional module beyond the life cycle of the asset that is intended to provide a broader view of its environmental impacts. This is Module D, the benefits and loads beyond the system boundary. This estimates any net kilogram CO2e benefits or loads beyond the project's life cycle associated with the recycling of material, For example, use of scrap steel, rather than virgin iron, in steelmaking on future projects. The energy recovered from materials, for example, energy generated by incinerating timber products. And the full reuse of materials or products when compared to the standard practice or standard product it would be replacing.
So how can we reduce the carbon emissions in buildings?
Reducing carbon emissions in construction is crucial for mitigating climate change. One effective strategy is to focus on reducing embodied carbon, which is the carbon dioxide emitted during the manufacture, transport, and construction of building materials. Prioritizing the use of low-carbon materials, such as recycled steel or sustainably sourced wood, can significantly lower emissions. Additionally, improving the energy efficiency of buildings through better insulation and passive solar design reduces operational carbon emissions over the building's lifetime. The construction process itself can be optimized by using energy-efficient machinery and vehicles, and by planning logistics to minimize transportation emissions. The adoption of construction management software, like Candy project control software, can also help reduce waste and improve resource management. Collectively, these measures can contribute to a substantial reduction in the construction industry's carbon footprint.
Now that we have explored the basics of carbon factors, let us explore how Candy project control software supports the estimating of carbon factors for a project. Candy focuses on the upfront embodied carbon, specifically the product stage, which is modules A1 to 3, as well as the construction stage, which is modules A4 to 5. Before importing carbon rates into Candy, they must be sourced and organized in an Excel table that aligns with your project's scope and requirements. Carbon factor rates can be sourced from a range of reliable resources, including supplier-specific environmental product declarations, or EPDs for short, that will supply carbon rate information for mainly modules A1 to A3. It also can be sourced from the EC database maintained by the Building Transparency Organization, or from carbon databases such as the Inventory of Carbon and Energy, or ICE for short. It can also be sourced from Carbon and Price Book, included in the Civil Engineering Standard Method of Measurement, 4th edition, or the CES MM4. These are just a few of the widely used sources available. Important to note, when sourcing carbon factors, especially when using AI like Copilot or other databases, always verify the geographic relevance and data here to ensure alignment with your project's specific context and requirements. Importing carbon factors into Candy can be imported in two ways. First, a single summarized or combined carbon rate factor for modules A1 to 5 that can be imported per price code or per bill item. Secondly, directly into the resource list using one or more of the 4 available carbon rate columns. These columns are A1 to 3, which is the combined production carbon rate, column A4, the transport to site, column A5, the installation on site, or column A1 to A5, which is the total summarized rate across all modules. Let us first look at how to import carbon rates for resources. When importing carbon rates for resources, there are certain import rules to take note of on how Candy handles the data import for the resource list. To import carbon rates into Candy, the relevant resources must already exist in the Candy job and be assigned a valid resource code, which serves as a key reference for the import. Note that carbon rates are only imported or updated for simple resources. For complex resources, carbon rates are automatically calculated based on the associated simple resources used in their build-up. When individual carbon rates, that is rates for columns A1 to A3, A4 or A5, are imported, Candy sums them to populate the A1 to 5 total or combined column. If only a summarized total rate for the combined column A1 to A5 is provided, it can be imported directly into the A1 to A5 total column as a plug rate. But it's important to note, if both a total rate and individual rates are imported for resources, Candy prioritizes the individual rates. The summarized or combined total is then calculated from these inputs from columns A1 to A3, A4 and A5. These rules might be best explained in a practical example. To demonstrate how to import the resource carbon rates from an Excel file, we will be using a generic Candy job containing non-specific resources, price codes and bill items. Within the Resource Document Manager, we have pre-configured some layouts with relevant columns to support the demonstration of how to import the rates. These layouts were adapted from the default template, namely 1.10 Resource Carbon Analysis, and this template was customized to suit our requirements. With the resource list open, customize as required, showing the carbon rates columns, you can export this to Excel by simply going Tools and choose either Write to Excel, which is a fast method, or Export to Excel, which will open up Excel and populate the information inside the Excel file, as you can see there. On the screen, we currently have both the Excel file and the Candy application displayed. To demonstrate the previously mentioned rules, the Excel file has been set up as follows. The file includes rates for both simple as well as complex resources. Refer to the complex resource, code 520. Rates are distributed across 4 columns. The first 3 individual rate columns, A1 to A3, is one column, A4 the other column, and A5. Then in the combined column, there's also rates, which accumulates the rates from the individual columns. Resource code 1 and resource code 4 have rates populated in both the individual columns as well as in the combined column to demonstrate how this will be handled. We have introduced a counter type resource designated by resource code 999, which will be explained in more detail later in the presentation. Carbon rates can be entered manually as already entered for resources 9 to 12, so there's no need to demonstrate that. But carbon rates can also be imported from an Excel file as follows. There's 2 ways to get to the import menu. First, Tools, Import carbon rates from a file, or go to the A1, A5 column, where you can see the little indicator with the blue star indicates that there's column options. So right click on the header to make the column selected, and inside the right click menu you can also see import carbon rates. Let's use that method. Click on import carbon rates. It'll open up file importing document. You can browse to where you've got the carbon rates stored. Select the carbon rates and open them. The part will now be in the text file name. Start the import. Okay. The import document will open up and you need to make some choices. You will notice that above each of the columns is the word ignore. In the sample window is all the data that you're bringing in from Excel, and you must tell the computer which column must go where in Candy. So we want to import the second column, that is the resource code column. So highlight the resource code, click on the green. Then it will move to the next column. We don't want a description column. Let's skip all the columns, go back to this column here. That is allowable column A1 to A3, so select that, number 3. The word ignore gets replaced with A1 to A3. The next column is A4. And the column after that is A5 carbon rate. And the last column is the combined carbon rate. Right, we will also notice there's 2 lines in there that we don't want. It came in from Excel. So we're going to ask the computer to ignore the 2 lines. Right, you'll notice when you type it in, it grays out. Press continue. We warn you that although you might have A1 to A5 as well as the combined column, the A1 to A5 fields will override the combined rate field. So we say yes, we're aware of that. Resource is amended, complex is skipped, and the line is rejected. Right, once that comes in, there's also a document that tells you what was rejected. And as you can see, any new resources that didn't exist in the job will not be added. You have to first import the new resources as a normal resource. Refer to the help portal, how to do that. And then you also notice that any complexes that do have values next to them is also ignored. Let's close that. And now we can see what happened. Let's look at resource number 1. So the sum of that total is 9.9, where in A1 to A5 column we added 10. So the 10 was ignored because we had, in the 3 individual columns, we had values, and that values is now summarized as 9.9. Same goes there. There was no A1 to A5 combined total, so it adds up, and you'll see the little green dot. If you hover your mouse on that, it displays that it is the sum of A1, A4, and A5. Right, as we mentioned, look at resource number 4. The same happened there. We had a value in A1 and A3, as well as in the combined column, a value of 8. That value didn't come through because of the rules, so only 6.2 came in, and that is the total that's displayed in the combined column. Once you've done that, you can calculate, and now you'll notice that complex 1 also now has values, A1 to A4, A5, and a combined value of 25.8 based on the symbols that's used inside the complex. Next, we're going to look at how to import carbon rates for price codes or bill items and see the rules applicable in that scenario. Carbon rates can also be imported for price codes to calculate and display the total carbon factor associated with the related bill items. On the screen currently is both the Excel file and the price code list for the current job. The Excel file was generated from a predefined screen layout document. As mentioned before, you'll set up the template and add and take away columns required, and then export that to Excel. The Excel file now includes the price codes that's applied in the job, and the associated carbon rates for each price code was entered, and these rates were sourced from external references mentioned earlier. The price code document shown below already reflects calculated carbon rates, and these rates were derived from the imported resource level carbon factors that we've just imported that contribute to each price code. To import the price codes, we've opened up a default document from the price code document manager. So we added new document, price codes and price code carbon analysis. We've already done that. Then we went and customized the document and remove the columns that we don't want and just leave the carbon rate columns there. Right, that document we've opened, and that's the one on the screen, and that's the one we also dumped to Excel to fill in the relevant carbon rates. Right, to import the carbon rates from the Excel file, do the following. Go to the combined column A1 to A5, right click on the column, choose the option Import Plug Rate Columns. Right, it will open up your browser, browse to price code carbon factors, open that up. So as mentioned before, you need to replace the word ignore with the relevant column that you want to import the data into Candy. So in the first column, we'll use the price code. We'll skip these two columns. We go to the carbon rate column, plug rates, confirm that. In this case, we will only change the first line. And once we've got that, we can say continue. Okay, And notice carbon rates came in when we can calculate that. And what you will notice is that the carbon rate that was previously calculated for items is no longer calculated. So item A, item F, and G didn't have any carbon rates in the resource buildup, but item A has. Notice that it overrides the individual columns carbon and only displays the combined column carbon that was imported, the 31. However, if you clear the carbon rates, you will see that it goes and populates back the previous imported carbon rates. Okay, so you can also manually type in the carbon rate. So let's make that 30. And do you want to overwrite? Yes. And now it only has the plucked carbon rate. And then obviously you can calculate and the whole job will be updated. To recap, carbon rates for resources can be imported for the individual modules A1-3 to modules A5 or for the combined total column A1 to 5. However, if rates for both the individual modules and the combined total are present, the combined total will be overwritten with the sum of the individual modules. Note, only combined total rates can be imported for price codes, and it will override any existing individual module rates. Next, we'll use a sample job to see how to analyze the carbon rates that you've just imported. Let us consider a simple generic sample to illustrate the carbon analysis function in Candy. In this example, we use a small crusher building as a sample project. Bill items was created, and the quantity takeoff function in Candy was used to measure the associated quantities. Let's look at what the building looks like. So we're going to look at the quantity takeoff manager. There's the crusher building package. Let's open the package and see what it looks like. And on the screen is the takeoff application that's free together with Candy. So we've brought in a PDF drawing from the crusher building. Let's open that and see what it looks like. Let's look at the measurement folders that we've already been created. So there we've got a measurement for the site clearance, foundation excavation, concrete, both the surface bed and the first floor slab, and the columns. Those items were measured. The measurements were connected to the bill items via the takeoff sheets. Let's look at the site clearance. As you can see, there's a takeoff list, there's a site clearance, and it's connected to the bill quantity. That was transferred to the bill items in the BOQ, and the quantities were summarizing, consolidated, and that is what we see in here. The bill items were priced using worksheets. So let's open a worksheet, see how it was priced. There we can see the relevant resources. As you can see, it's highlighted in red, so that indicates it's a complex. So let's look at the laborer. The build-up of 160, 120. Let's drill down. If you double-click, it'll open up the next level of worksheet. It consists of a basic rate, an on-cost rate, and a travel allowance. The on-cost rate is a build-up. So let's drill down. 2920 was built up by the Holiday Fund Pension Scheme. And you'll notice that we've also now added a carbon counter factor. Now that was done on the lowest level of the complex because carbon factors can only be allocated to simples and not complexes. So let's see what was done. So let's go back there. We've created a new resource called carbon counter laborer, and very important, the resource must have a rate of 0 because we're only interested in the usage. And then to indicate that it is a counter, we right click in the attribute column, we counter and set it as a counter, and then you'll see a letter C in the attribute column. So let's scroll up and see, let's just close a couple of things here and let's go to the laborer. So let's close the plant, temporary material. Right, so there's the laborer. Okay, as you can see, it's a complex. Now let's see where this laborer was used. So we cross-reference in all the bill items based on the bill quantity. And there is the relevant bill items where this laborer is used inside the worksheets and all of those worksheets. The usage for each worksheet, in this case obviously usage per day, and the total usage is summarized, 3162. right? So we see there, that's the 3162. The carbon factor that was entered or imported was 0.80, and there is the 0.80 times the 3162 will give you total carbon factor for the laborer on this job of 25.33 kilograms. Right, some other functions that you might find handy. If we want to look at the kilograms, we can graph the usage, let's say, of all the items based on the resource code or the resource description. Let's use the resource description. And there you can see a graph, and you can see from highest to lowest. You can copy it to a clipboard and use it in any one of your reports. You can also go and say, let's just look at the top 50%. Say, okay. And now we've only got a selected view and graph of the top 50%. And we can copy that to the clipboard and use that. Another tool also available is the shell threshold visualization. So right click, select the shell threshold. Let's say we want to see everything above 1000 kilograms. Confirm. Click on the cell. Green. It's all right. Below the threshold, above the threshold is all the concrete items as well as the formwork items. To remove it, untick the box, clear, and OK. In Candy, allowable wastage can be incorporated directly into worksheet calculations. This allowable wastage can also be displayed on screen or in reports. To demonstrate this functionality, we have prepared a screen layout document that includes the relevant columns for both wastage and carbon-related values and amounts. We added some wastage columns, the allowable wastage. Added carbon columns that we want to see. And let's go and look at what we see. So there's the allowable wastage or the allowable wastage amount. There's the usage currently and the total allowable carbon factor in kilograms. So at the moment we see it's 14.4 tons or 14,400 kilograms. And that is including wastage, because we can see there, bill BOQ only including wastage. As mentioned before, once you see a blue star, it tells you that you can change the columns and the contents of the column. So let's go and do that. Right click on the column, choose the column options menu. As you can see, include wastage is ticked. Let's exclude the wastage. Now the net amount comes down from 106,000 to 103,000, and the tonnage comes down to 13,500. Okay. So basically the 103 plus the 295 will give you the total including wastage. Just to prove it, let's go and include the wastage again. Right, and now we've got 106,000 and the carbon is 14,000 kilograms CO2e. So the carbon wastage for the wastage alone would be the difference between the 14,400 kilogram CO2e, including wastage, and the 13,500 kilogram CO2e, excluding wastage. In Candy, the carbon usage can be displayed on the worksheet as well. Let's close this resource document. Let's open up a bill document, open up a worksheet. At the moment, we see the rate in the headers. Let's change that, clicking on View, Display Carbon Usage in the header. There's the carbon usage. And as you drill down through the different worksheets, that's complex worksheets for the tipper, wet and operator. If we drill down by double-clicking on that, there's the build-up. And there's the carbon now for that specific complex. If we go to the driver, that's a complex as well. So double-click, drill down, and we see the carbon unit. And if we drill down further to the cost, we also see right down to the carbon factor that we've put in, and there's the carbon unit for this specific complex worksheet as well. Let's close everything. In Candy, you've got unique ability to link the bill items to planning activities, and so produce a forecast either by money and also now by carbon factor. So let's look at the program first. So we go to the planning module. There's a very simplistic program that was created. This program is already linked to the bill, so let's look at that. So click on Link and Forecast, Document Manager, and let's now go and look at the activities of BOQ allocation that has been done. So there you can see the activity and all the bill items that's linked to it. And obviously that creates the money, the net amount per activity. We can also see the forecast. So let's look at the budget forecast, bill with budget forecast. So there's the money forecast, money over time. We can also see the carbon forecast. Bill with carbon forecast. We've just customized the document to suit the relevant requirements. So there you can see the customization that's been done. And now you can see the forecast over time. Let's close it up and look at, so the earthworks separately. There's the earthworks items. And here is the concrete and the formwork. And control space bar. You can also go and change, like a lot of changes here. Column properties as before. You can change the financial period or the period that you want to look at. Either last calendar day of the month, fixed day of the month, 25th, or any other options that you want there. Once you've done it, it's changed. So let's change it back. Last calendar day of the month. Okay. And you can also go and change what you want to see as far as the carbon is concerned. The combined carbon is displayed at the moment, but you can show the A1 to A3 only, or the A4 only, or the A5 only. What you can produce on the screen, you can also produce in the reports. So let's close this document and let's go to the report manager. Right, there's reports that we've already set up. So let's look at the carbon or forecast. Here you can see the bill items with the carbon forecast that you can print out. You can also have the carbon forecast summary. Okay. Now it's just a header summary, summarized by bill header. On the estimating side, if you open that report manager, there's a couple of reports already created for you. And it's just a matter of setting it up and showing it. There's also the carbon summary including wastage and the carbon summary excluding wastage. There's the summary. Okay, one thing that you need to take note of when you customize a report, you'll have the columns. You have the columns that you can add and remove. And you'll notice, like you had on the screen, that you have a little asterisk also with some of the columns. Remember the blue little star that you had? So that tells you the column has got options that can be changed. And that's where the new tab comes in, which says column options. And then you've got the relevant columns that do have the change asterisks available. And you can just right click in the options to change what you want to see: bill quantity, direct cost only, include wastage. For exclude wastage, if you untick the box. It's been set up as including wastage. And then obviously when you preview that, that will be including the wastage. Right, let's close that. Let's clear the screen and explore how Candy can be used to propose alternative methods and resources for minimizing the project's carbon footprint. When analyzing a project, there are several functions you can apply to help reduce its carbon footprint. One particular useful function is the use of a global variable as a switch to compare alternative construction methods. In this example, we have defined a global variable, RMC, under the price code definitions. This variable acts as a toggle to analyze the difference in both total project cost and carbon footprint when switching between site batching and ready-mix concrete. To enable this comparison, the worksheet includes calculations for both alternatives. The applied factor for the ready-mix concrete is multiplied by the global variable RMC, and since the RMC value is currently set to 0, all ready-mix rates evaluate to 0. Conversely, if the site batching calculation are multiplied by the factor 1 minus RMC, which then equals 1, this will result in the active values for the site batching resources. As a result, the current rate for this price code is 698.84. As the resource has been allocated carbon factors, the carbon factor per unit for this worksheet is 189 kilograms per CO2 To simulate the impact of using ready-mix concrete, simply change the value of the RMC from 0 to 1. This switch will activate the ready-mix calculations and zero out the site batching values. Under this scenario, the rate for the same price code becomes 821.45, and the carbon factor per unit for this worksheet has now changed to 307 kilograms per CO2e. Let us now look at a live example to see how the switch affects both the carbon factors associated with the concrete price codes and the overall project footprint. Right, let's look at this job. Let's open up the carbon analysis, total only. So here we can see the total net amount for the project is 106,308, and the carbon CO2e is 14,454. As we're going to change the concrete, let's close the earthworks and just look at the concrete total. At the moment, 45,722 and 12,145. Currently, the value for the RMC switch is made 0. So that is why you've got that total. Let's change it to 1 and recalculate that. So now we want to see what happens if we ready mix. Say OK. Go back here. You need to calculate. Calculate button is red. Click on calculate. There you've got the change. Contract went up to 108,314. And the combined CO2e went up to 19,891. Concrete value 47,728, and total combined allowable carbon CO2e went to 17,582. To apply the global variable switch, we incorporated all required resource rates and their associated carbon factors in the resource list for each method. Each method was then priced and included within all the concrete worksheets, allowing the values to be calculated for each option for all concrete worksheets by simply changing the global variable switch in the definitions. The result indicated that site batching concrete, as opposed to using ready mix, is the better option in terms of both cost efficiency and carbon footprint for the project. Candy includes a function that enables the submission of alternative tenders. In this simplified sample, the original conforming design consists of a concrete slab supported by concrete columns. We are proposing two alternatives. Option 1, a concrete slab supported by a steel frame. Option 2, a cross-laminated timber CLT slab supported by a steel frame. These alternatives are intended to explore potential reductions in carbon footprint. We also aim to assess the impact of each option on the overall monetary value of the project. In using the alternative tenders, first a parent job gets created. So here we've got the parent job already created. Under advanced alternative estimates, you define the alternative estimates, define your conforming job, you define the other two options in there, and then you decide if the options is changed by entering alternative quantities or factors. In this case, we choose alternative quantities as a normal quantity. Say OK. Then we went to the specialized bills, open up an alternative estimate parent only. We add the additional single brace steel frame items with their resources and their carbon factors, and obviously then that will zero out their conforming bit. And we add the cross-laminated timber, and we add the relevant quantities, in this case 0 for the conforming bit and the 0 quantity for the concrete slab on a steel frame. And then we obviously alter the relevant concrete items with quantities as required. Once we've done that, from there we'll create first the conforming job. Look at the conforming job. Go in there, do the carbon analysis. Let's look at totals only. Once it's calculated, we look at the 106, which we had before. That's now the site batching that we decided, and the 14,445 combined total. Right? From the parent job, we create option 1. It's already been done. There's option 1. Let's go to the carbon and see what that's the result. Let's open that up. Option 1, Carbon footprint came down, 13,280, but the bill amount went up to 345,945. Right, let's look at option 2. So let's go back. Option 2 is created from the parent job. That's the CLT slab on steel frame. Let's go and look at the end result for the carbon. So there we have 8,800 for the carbon. It came down quite dramatically, but the amount went up to 446,260.38. In comparing the conforming job with option 1, the results indicate a carbon footprint reduction of just over 1,000 kilograms CO2e. However, this comes at a significantly higher overall project cost. Option 2, by contrast, offers a substantial reduction in carbon emissions relative to the conforming job, but also results in a high total project value. This presents a compelling dilemma. Should one prioritize environmental benefits over financial cost, or the reverse? A decision must be made, and the outcome will reveal which holds the greater influence: moral conviction or monetary constraint. Let us look at other carbon-related requirements to be considered. Please advise what is the publicly available specification or PAS 2080 standard for carbon management.
PAS 2080 is the UK's publicly available specification for managing whole-life carbon in buildings and infrastructure. The 2023 revision expands its scope to include both infrastructure and buildings, emphasizing early collaboration, leadership, and systems thinking to support the transition to net zero. The standard is built on 5 key principles. First principle is leadership and governance to embed carbon thinking at all levels. Second, whole-life carbon assessment, from design to decommissioning. Third, is early-stage decision-making to influence outcomes. Fourth is collaboration across the value chain. Fifth is monitoring, reporting, and continual improvement. PAS 2080 clearly defines the roles of each value chain member. The asset owners or clients must set carbon ambitions, lead governance, and ensure carbon is embedded in procurement and delivery. The project managers and supervisors must coordinate efforts, verify compliance, and ensure carbon targets are met. The designers identify opportunities to reduce embodied and operational carbon through smart design choices. The contractors implement low-carbon construction methods and monitor site emissions. The product and material suppliers provide transparent carbon data and innovate toward lower carbon alternatives. The sustainability advisors support quantification, reporting, and continual improvement. By aligning with PAS 2080, organizations can reduce emissions and costs, improve tender competitiveness. They can demonstrate leadership in sustainability and contribute meaningfully to climate goals. In summary, PAS 2080-2023 is not just a technical standard. It is a collaborative framework for transforming how we design, build, and operate in a carbon-conscious world. Success depends on every stakeholder understanding their role and acting with purpose.
Please explain NEC4 option X29, climate change clause.
Option X29 is a secondary clause introduced in July 2022 for all NEC4 contracts to help clients and contractors integrate climate change requirements directly into the contract. It transforms sustainability from an aspiration into a contractual obligation, supporting the industry's shift toward net zero. X29 introduces 5 key components. 1. Climate change requirements. Defined in the scope, these are mandatory sustainability obligations. 2. Climate change plan, a contractor-led strategy outlining how the requirements will be met. 3. Performance table, optional KPIs with incentives or penalties tied to carbon targets. 4. Climate change partners, stakeholders identified for collaboration throughout the project. 5. Early warnings, required if anything threatens the achievement of climate targets. Each party has a defined role under X29. The client sets the climate change requirements and identifies climate change partners. They lead by embedding carbon goals into the scope. The project manager oversees compliance, manages changes to the scope, and ensures alignment with contract processes. The contractor develops and implements the climate change plan, proposes innovations, and reports performance. The supervisor verifies that the works meet the technical and sustainability standards. The subcontractors and suppliers collaborate with the contractor to deliver low-carbon solutions and provide transparent carbon data. The sustainability advisors support quantification, reporting, and continual improvement. X29 ensures that carbon management is not left to chance. It aligns with standards like PAS 2080, encourages early collaboration, enables measurable outcomes, and supports a consistent, legally enforceable approach to climate action. Failure to meet climate change requirements, if related to the works, is treated as a defect. The climate change plan itself isn't enforceable, but it guides delivery. In summary, NEC4 Option X29 helps align construction projects with net zero goals, encourages innovation, and ensures climate considerations are not just aspirational, but contractually enforceable. X29 empowers project teams to take meaningful, accountable steps toward carbon reduction. It is not just about compliance, it is about leadership, innovation, and building a resilient future.
Explain the carbon border adjustment mechanism that is being proposed.
The Carbon Border Adjustment Mechanism, CBAM for short, is a policy proposed by the European Union to address the issue of carbon leakage. This occurs when companies move production to countries with less strict climate policies or when EU products are replaced by more carbon-intensive imports. Here's a simplified explanation. Purpose: CBAM aims to put a fair price on carbon emissions from goods produced outside the EU but imported into it. How it works: importers of certain carbon-intensive goods, like cement, steel, and aluminum, will need to buy certificates that reflect the carbon emissions associated with those products. Goal: ensure that the price of carbon is the same for both EU-made and imported goods, encouraging cleaner production methods globally. The mechanism is designed to be compatible with World Trade Organization rules and will be fully implemented by 2026. The cost of CBAM certificates can vary depending on several factors, such as the type of product, the country of origin, and the current carbon market prices. In the European Union, the CBAM is set to be implemented in 2026, and the initial carbon price is expected to be around €65 to €90 per ton of CO2. However, this price is subject to change as the global carbon market evolves. To give you a better idea, let's consider a hypothetical example. A company imports 100 tons of steel from a country with less stringent environmental regulations. The CBAM certificate cost for this steel shipment might be around €6,500 to €9,000 for 100 tons at €65 to €90 per ton. This cost would be in addition to the actual cost of the steel and other associated expenses. Keep in mind that this is a simplified example, and the actual cost of CBAM certificates may vary depending on various market and regulatory factors. The construction industry is likely to feel the impact of CBAM costs in several ways. The Carbon Border Adjustment Mechanism, CBAM, will significantly influence the construction industry, particularly due to its reliance on carbon-intensive materials like steel, cement, and aluminium. Here is how it might impact the industry. 1. Increased material costs. CBAM will impose additional costs on imported materials with high embedded carbon emissions. This could lead to higher prices for essential construction materials, impacting project budgets and timelines. 2. Shift to sustainable practices. To mitigate costs, construction companies may prioritize low-carbon materials, such as recycled steel or alternative cements, and adopt greener construction techniques. 3. Supply chain adjustments. Companies might shift to sourcing materials locally or from suppliers with lower carbon footprints to reduce CBAM-related expenses. 4. Pressure on margins. For firms operating on tight margins, these additional costs could pose financial challenges, potentially leading to increased project costs or reduced profitability. 5. Innovation opportunities. CBAM could drive innovation in materials science and construction methods, encouraging the development of sustainable alternatives and energy-efficient practices. 6. Compliance and reporting. Construction firms will need to enhance their carbon accounting and reporting systems to comply with CBAM requirements, ensuring accurate tracking of emissions embedded in materials. 7. Market differentiation. Companies that adopt sustainable practices and align with CBAM goals may gain a competitive edge, attracting eco-conscious clients and projects.
With the recent development in the world, will reciprocal tariffs from the USA influence CBAM?
The USA's reciprocal tariffs, which impose duties on imports based on the trade balance with each country, could escalate trade tensions with the EU. If CBAM is perceived as a trade barrier, the USA might retaliate with additional tariffs on EU goods. The EU has designed CBAM to be World Trade Organization compliant, but reciprocal tariffs from the USA might challenge this compliance, leading to disputes over whether CBAM constitutes unfair trade practices. Only time will tell. For additional details on the carbon factor emission topics covered in this webinar, please refer to the relevant website links and QR codes in the following slides. If you are watching the recorded playback, you may pause these slides to manually enter the web page links or scan the QR codes for direct access to supporting sources. This gives you an opportunity to explore these resources at your convenience to gain deeper insights. Thank you for your time.
As we came to the end of the webinar, we want to remind you of the Help Center menu in the software. More information, including any previous webinars you might have missed, can be accessed through the Help Center menu in the software. By selecting the Help Center menu, you'll be redirected to the RIB support portal, and once there, choose the RIB Candy option to open the RIB Candy support website. The RIB Candy support website serves two main functions. 1. Access the knowledge base where you can search for detailed guidance on Candy software features and functions. And 2. To submit a support case. If you encounter a software error, can't find the information you need, or wish to suggest a new feature, click on the Contact Support link under the Get Support title on any product page to submit a case. This alerts the support team, ensuring a prompt and relevant response. Note, registration on the support portal is not required to access the knowledge base or to submit a case. However, to track the progress of your cases or retrieve responses to previous queries, you may register directly on the website. Once logged in, you can monitor your submissions under the My Case section. As a reminder, we offer online as well as in-person training courses from basic to advanced. We also offer consulting on specific functionality and features within Candy to get your team equipped to get the best out of Candy. We host in-person and virtual seminars focused on various topics to assist in using Candy to its fullest potential. Regular webinars on various topics are also scheduled. Product advice and telephonic supports are also available. Please contact your local RIP Candy offices for more information. Keep in touch with our latest news, announcements, and upcoming events by following us on our social pages. Search for RIB Software on Facebook and LinkedIn, or scan the relevant QR code currently available on the screen to stay connected. We hope you enjoyed this webinar and found it insightful. Should you require any further information, kindly contact your local RIB Candy offices. Thank you for attending and enjoy your day.